so let's look at our next example. It says solve using the elimination method. I have y equals 3x plus 4 and 2x minus y equals 5. I know that the first step is usually to stack them underneath one another, but there's a problem here. They are not in the same form, so even if we do stack them, it will do us no good. I'm going to tell you right now, the best tip I can give you is whenever you notice that the two equations are not in the same form, you want to put it in standard form. And just a quick reminder for you, standard form is ax plus by equals c. What does that mean? It means your variables are on the same side and your constant is on the other side. So that is my goal. Get all my variables on the left side and leave my constant on the right. So which equation am I going to have to change? I'm going to have to change the first one. Why? Because not both variables are on the left side, but my constant is on the right side. If I look at the bottom one, it's ready to go. Both of these variables are on the left side, and my constant is on the right. So let's go ahead and do that. I'm going to go ahead and subtract 3x from both sides right here on the first equation in order to get it into standard form. And when I do that, I'm going to get negative 3x plus y equals 4. And again, this second equation is already in standard form. I do not have to touch it. All I'm going to do is rewrite it. And now they're stacked. They're ready to go. I'm going to go ahead and combine like terms. Here, I'm going to realize that the y values are going to cancel each other out. Again, why? Because they are inverses of one another. And we know that when we combine inverses, they're always going to give us a sum of 0, which is exactly what we want because now they are eliminated and I'm just going to work with my x values. So I have a negative x, 3x, and a positive 2x. When I combine them, I'm going to get a negative x. I'm going to combine the 4 with the 5, and that's going to give me 9. So I have left over a negative x equals 9. Am I done yet? Not quite. I have a negative x, and that's not what I want. I want to know what x equals. So how do I do that? Well, first we need to remember that there is an imaginary 1 in front of that x. And how do I get rid of that coefficient? Well, all I have to do is divide both sides by a negative 1. Why? Because that way my negative 1's will cancel each other out, just leaving me with x equals negative 9. Bam! I have solved one of my variables, so things are looking good so far. Now all I have to do is I'm going to go ahead and substitute a negative 9 into the x. I get to choose whichever equation I want. I can choose the first one, I can choose the second one, but again, I personally would choose the first one. The reason being is because I already have an x value. I am looking for my y. And in this particular equation, it's already set up as y equals blank. So when I plug it in, I'm not going to have to do much. Please understand that I could possibly plug it into the second equation, but that's going to require me to do a little bit more work. And personally for me, I want to do the least amount of work possible. So I'm going to go ahead and plug negative 9 into the first equation for my x variable. And again, I need to make sure I have the negative 9 in parentheses, otherwise I risk the chance of changing my entire equation. Now I'm going to simplify. I'm going to get negative 27 plus 4. Simplify it one step further. I'm going to get y equals negative 23. I'm almost there. Last thing I need to do is I need to write it in the format of x comma y, making sure the solutions are written with parentheses because yes, they are important. But again, before you leave this problem, you need to make sure you check your work. It's going to be a requirement on your homework. If you don't, you're not going to get full credit. So please make sure you check your work. How do you do that? You're going to plug in negative 9 for all the x variables, and you're going to plug in negative 23 for all your y variables. Do they need to work for both of the equations? Of course. They can't just work for one of them. They need to work for both. If you realize when you check your work that one of them only works, you know you did something wrong, go back into your work to find the mistake and fix it from there. So that concludes our second example.